Hello students, today you're going to take Cornell notes on Introduction to Magnetism. Go ahead and set up your notebook. This is a good time to pause the video and set up your notebook. This video will have a short lecture at first, and then you all will have time to copy all the notes. Okay, let's begin. In this video, we're going to focus on the idea of magnetism, and then we're going to connect this idea to the idea of electricity and what is the relationship between both of them. But in this video, let's quickly and briefly talk about magnets. Magnets usually attract metallic objects, so like this paper clip here. Usually one of the properties of magnets is that they have two poles, so north and south pole. Even if you cut a magnet in half, then you would create a new south pole and a new north pole. And they have an area of influence called a magnetic field. In the magnetic field, closer to the north and the south pole are strongest, and these areas are a little bit weakest. And as you move away, the magnetic field becomes weaker. And it's an invisible field. Not all metals can become magnetized. So nickel, cobalt, steel, iron, these are examples of metals that can become magnetized. Other metals like gold really don't become magnetized. And then paper, glass, plastic, rubber, wood, these are all examples of materials that cannot be magnetized. So what is causing material to become magnetized? Let's say like the steel paperclip. So use a very powerful microscope over 250 times of magnification. You would see these pockets within metals called domains. These are pockets of atoms. Within these domains, in most metals, some of the magnetic field pockets are all scrambled up, which cancels the magnetic ability of most metals. So this domain and this domain cancel out, let's say, and so the metal is not magnetized. But if you have domains where they're all pointing the same direction, or the atoms are arranged in a similar pattern, then the metal becomes magnetized. You can actually create a temporary magnet if you use a magnet on something, let's say like this steel needle. If you go over in the same direction, you start to move around the domains, and the magnetic fields start to go in the same direction, and then the steel needle can become temporarily magnetized. Things like heat or shock can cause the magnet to lose power or become demagnetized completely. Okay, now it's time for the Cornell notes for today. So go ahead and take a few minutes to write them down and then move on to the next thing. Have a great day.